Welcome to Understand the Math. In this video, I'm going to show you how to convert a polar equation to a rectangular equation. I've listed 4 techniques to convert our equation to one of these forms. The first technique that we can use is to simplify the equation using a trigonometric identity. The second technique is to substitute in r cosine theta is equal to x, r sine theta is equal to y, or tangent theta is equal to y over x. Another technique that we can use is to multiply both sides of the equation by r. And the last technique that we can use is to take the tangent of both sides of the equation. The 4 equations listed here in this red box will help us know where to start. When you work on problems like this, it's a really good idea to write down these equations before you begin. The first equation that we'll look at is theta is equal to pi over 4. The only equation in the red box that has just theta and not r in it is tangent theta is equal to y over x. So let's take the tangent of both sides of the equation. On the left, we have tangent theta, and on the right, we have tangent of pi over 4. Tangent theta is equal to y divided by x, and tangent of pi over 4 is equal to 1. We can then simplify this to the equation y is equal to x. This equation is a line through the origin at an angle of pi over 4. R can be any value along this line. Our second equation is r is equal to 5 secant theta. In our red box, we don't have an equation with secant in it, but we do have an equation with cosine in it. So we'll remind ourselves that secant theta is equal to 1 divided by cosine theta, and we can plug that in. This gives r is equal to 5 divided by cosine theta. Let's now multiply both sides by cosine, and we have r cosine theta is equal to 5. R cosine theta is equal to x, so our equation becomes x is equal to 5. This equation is a vertical line. Isn't it interesting that 5 secant theta is actually just a vertical line? Our last and hardest example is r is equal to 2 cosine theta. It looks simple, but it's actually the hardest one that we're going to do. In our red box, we have a cosine theta, but it's multiplied by r. So down in our equation, let's multiply both sides by r so that we can get r cosine theta. On the left-hand side, we have an r squared, and on the right, we have 2r cosine theta. We know that r squared is x squared plus y squared. And on the right, we have 2 times r cosine theta, which is equal to x. Now, unfortunately, we don't want to leave it like this. We're going to have to do some algebraic manipulation to make this an equation that we can actually recognize. Let's pull the 2x to the left and see what that looks like. We have x squared minus 2x plus y squared is equal to 0. If we put brackets around the x terms, we can see that this looks like a circle. To simplify this, we'll have to complete the square. So we're going to say x squared minus 2x is going to be equal to x squared minus 2x. What you do is you take the middle constant and you divide it by 2 and square it. Minus 2 divided by 2 is minus 1. So we'll add a minus 1 squared, and then so that we don't change the equation, we're going to subtract a minus 1 squared. This is going to give us x squared minus 2x plus 1 minus 1. Let's plug that in. This is x squared minus 2x plus 1 minus 1 plus y squared is equal to 0. The x's we can combine to be x minus 1 quantity squared, and then we have our y squared, and our 1 can go over to the right-hand side and be equal to 1. This equation is now in a form that we recognize. This is the equation for a circle of radius 1 centered at the point 1, 0. I hope that you're now a little more comfortable converting between polar and rectangular equations.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.